Imagine if we could inquire of our data just like we ask questions of each other. What if hidden in our data were answers to problems we didn't even know existed? In this video, I'm going to show you a way to structure your data so that when you need to change that data, you might need to change things within it, change and add things to it. You don't annoy your customers, you don't annoy your developers because you've broken it by changing it, but actually you enhance their lives, you make their products better. In the English language, we construct our sentences in this kind of way. David loves flying. Flying frightens John. What do we have here? Well, David and John, they are specific people, entities. Flying is something we do, and loves actually describes the relationship between, in this case, in this situation, David and the action of flying. Now, as humans, we know what's loves, we know what's frightens, we know these meanings, and hence these two sentences give us enough information that we can actually ask questions like, who likes flying? Or, who's frightened by flying? What does David love? We understand this because of the semantics of what we say. Through this semantic process, we have enough information to take action. I want to take you on a journey from traditional data models to a semantic data model. A data model that will allow us to ask questions of our data like we just discovered: who loves to fly? Who's frightened to fly? Am I saying that this old traditional way of modeling data is wrong? No, I'm not. This is just another way to model data. And in the day and age of the World Wide Web, of apps sucking data from the internet, this may just be an amazing way to model your data so it can be used and used well. It may be a way to model your data so you can find answers to questions, that you can discover new knowledge already in the data you have. Probably the simplest data model is the tabular data model. An Excel spreadsheet, an Apple numbers spreadsheet, or something similar. Super simple, really convenient, easy to read, understand, and we can manipulate it. Data in a table has semantics. What the column we put something in is what actually gives it the meaning. If it goes here in the name column, or the address column, or the price column, that data now has meaning. We do hit limitations with tabular data. Looking here, without opening hours, okay? Easy to read, but now difficult for a computer to sort or to understand what the column is actually telling us. From tabular data, we tend to move to what's called relational data. Now, the vast majority of databases use this model, hence they're called relational databases. Now, what does it do? Well, it allows tables to be joined together in a really standardized manner. Our original data set could now be modeled like this. I can now do a reasonably complex query on that data. I can ask what restaurant will be open on Monday afternoon, and it's going to give me the answer. In this model, the semantics are more explicitly exposed. Looking at the table schema, we can start to understand the data because of the description of what is in there. Okay? The relational model is fantastic, especially when the way the data is structured is really well understood and the way the data is going to be used is extremely predictable. As you know, data changes, there's data updates, and this means we need to cater for these changes. In our situation, we've got our restaurant database, but now we have a new database of bars, and this database has more information in it that's not in our restaurant database. One of the restaurants is a bar and has a DJ and does specialty drinks. But we have this information in two databases. So let's fix our database by adding another table with the information in it. Here we go. Now we have overlapping information. Oops. And we have to check two tables about an address. A restaurant has a cuisine, but does a bar have cuisine? Let's make a change and fix this. We now have hours, venue, bar, and restaurant all sorted. Hang on, our data is still in the old database though. So let's transform and move the data. Easily said, easily done in this situation. But when we've got large data sets, this can be a massive issue. What about our customers who use our data? What about any developers who use our data? We've just changed the structure of our data. Their apps, their web pages, none of them work anymore because we changed the data schema and what they're sucking out is no longer there. It's structured differently. What have we done? We have successfully annoyed our customers, annoyed our developers. These are the people who use our data. A change that we made may have cost them a lot of money. It may have cost them their business. We need to think about that with our data structures, with our data models. How do we create these data structures so we can add to them without breaking everything in them and annoying our developers and our customers? What if we could make it so we could include new purposes, give custom fields for this to occur in our example? So it's no longer about bars and restaurants, just venues and custom fields. Now, if you're a database administrator, okay, at this point in time, you're going, no, you just broke the normalization. You've degraded the performance of the database. If you don't know what I'm talking about, don't worry about it. For the database administrators, hang on just a moment. Stick with me. It will be worth it. We now have the ability to add a new purpose to our data. Our properties table is capturing all of this custom information for us about the venues. We can keep adding venues to our data. Concert venues, spa venues, we just keep adding to it. And now I can start to ask the question, where can I stay that is near cheap food, has concerts close by, and when I'm exhausted, I can head to the spa? See how we've now added more rows into our properties table. The way it's structured is often known or called a key value schema. We've flattened everything to be key value pairs. Some database administrators consider this to be bad practice, but let's keep exploring it and see where we end up. I will now move all the relationships from the standard table rows into these parameterized key value relationships. What happens? Well, venue name and address are simply properties of the venue. The bummer, the relationship between the properties table and the field table is still only known through a join. So let's join these two tables and display it in the key value way. What do we end up with? Well, each datum is described with the property that defines it. We have taken the semantic relationship that was inferred in the table, and now what we've done is we've actually made it, or we've embedded it into the data within our table. So that relationship is now in there. Welcome to semantic data modeling. What does this semantic data modeling actually facilitate? Well, the relationships amongst the data are actually defined in the data itself. Our data model is a simple 3-column format which is known as a triple. The triple format is a fundamental data structure to build semantic relationships. A triple is a basic linguistic statement. Subject, predicate, object. That's it. John plays cricket. The subject is an entity, which is usually a thing. Okay, the predicate? Well, the predicate is the property of the entity which it is attached to. The object, well, is one of two things. It's an entity that can be the subject in another triple, or it can be a literal value. We can start to tie triples together using the subjects and objects within different triples. As these start to chain together, we are creating a directed graph structure. Now we can add some neighborhood data to that same table. We have venues and neighborhoods in our data model, but they're not connected. Now, because objects in a triple can be subjects in another triple, we can start to add assertions so we can specify which venue is in which neighborhood. And now we end up with this graph of our data. With all of this done, I can actually inquire of the data about where can I eat in San Francisco cheaply. We have now transformed our data from a tabular data structure, a tabular data model, all the way through to semantic data. We can easily add to our data, and even better, we can easily discover new knowledge that already existed in our data. We can find new knowledge that we didn't know existed within our data. It may have existed there, but it wasn't easily found or discovered. Now, through this simple triple format, we are able to extract that information, that knowledge, which may be new knowledge, which may give us understanding to things. This is semantic data modeling, where we can discover if the answers we seek are already in our data. Does David like flying? I'm David McMeekin, Kendani eBuck.